Welcome back. In this video, we are going to talk about the basic properties of gases and the theory that explains how they behave at a molecular level. Gases are all around us. Sometimes they react together like nitrogen and oxygen in our atmosphere, reacting to form that brown smog you see in cities. Other times, they are produced in reactions, like when you mix baking soda and vinegar to create carbon dioxide bubbles. We spend a whole chapter on gases because their behavior is so unique and predictable. To understand gases, we use the Kinetic Molecular Theory. This theory tells us three main things. First, gas particles are very small and move randomly at high speeds. Second, they don't really stick together because their attractive forces are very small. Finally, because the particles are so small and the spaces between them are so large, most of a gas is actually just empty space. And you can see that quite readily in this simulation here. Gas particles are in constant motion, zipping around in straight paths until they bounce off a wall or each other. This motion is actually how sound travels. Molecules bumping into each other transmits that pressure wave at the speed of sound. The most important thing to remember is that the energy of these particles is directly related to the Kelvin temperature. As I increase the temperature in this simulation, the particles move faster. And if I lower the Kelvin temperature all the way to 0 Kelvin, molecular motion itself completely stops. To quantify a gas, we use four specific variables. Pressure is capital P, and this is the force against the container walls. The typical units of pressure are atmospheres, millimeters of mercury, and psi, which we'll get into in a bit. Another variable is volume, which we use capital V, and there are no surprises here. We simply use liters or milliliters, and these are very common. For temperature, we use capital T. I wish we used capital K in the gas law formulas because the temperature always needs to be converted to Kelvin. To do that, you just add 273 to the temperature in degrees Celsius. We'll get more practice with that later. And finally, we have the amount of the gas, which we use symbol N, which stands for the number of moles. This is very common. We don't use grams, we use moles. And we're going to explore how these four fundamental variables interact throughout this chapter.